Tonight, you watch the sun go down the way you always do. It sinks behind the horizon. The sky turns orange, then purple, then dark. You barely notice because you've seen it 10,000 times before. But now imagine a second sun rising just as the first one sets. Not a trick of light, a real second star blazing in a different part of the sky, refusing to let the night begin. That's not science fiction. Somewhere out there, it's already happening. Astronomers have found real planets orbiting two suns at once. Not in a galaxy far, far away. In our own cosmic backyard, relatively speaking. In fact, binary and multiple star systems aren't some rare cosmic exception. Depending on which survey you look at, roughly half of all sun-like stars in our galaxy have at least one stellar companion, locked in orbit with a second star somewhere nearby. Single stars like our own sun, quietly orbited by planets with nothing else competing for their light, may actually be the less common arrangement. So what would it actually be like if Earth were one of them? Let's start with the sky itself, because that's the part your brain would struggle with first. On a two-sun world, there's no single sunrise and sunset. Depending on how the two stars are arranged, you might get two dawns, two dusks, or one long stretch of daylight with barely any true darkness at all. Some days would never fully end. Some nights would barely begin before a second sun crept over the horizon to interrupt them. Sounds exhausting, doesn't it? Your body would agree. Every living thing on Earth runs on an internal clock tuned to one rising and one setting sun, a roughly 24-hour rhythm called your circadian cycle. Sleep researcher Charles Czeisler at Harvard Medical School has spent decades proving just how deeply this cycle controls you, from your hormone levels to your body temperature to your mood. His research has shown that even small artificial shifts in light exposure, like late-night phone screens, can measurably delay your body's release of melatonin and throw off your entire sleep cycle. Now imagine that same disruption, except it isn't a phone screen. It's an actual second star sitting in the sky, refusing to let true darkness settle in. Break that single light-dark pattern completely, and you don't just get tired. Your entire biology starts to misfire. Two suns wouldn't just change your view, they'd rewrite your sleep schedule from the inside out, generation after generation, until an entirely different rhythm evolved to cope with it. What might that rhythm even look like? Some scientists speculate that species evolving under multiple light sources could develop shorter, more fragmented sleep cycles, catching rest in scattered bursts rather than one long stretch of night. On Earth, a handful of animals already do something similar. Dolphins sleep with half their brain at a time, staying alert with the other half. A two-sun world might make that kind of split partial rest the norm rather than the exception for every creature living under its sky. But here's where the story gets stranger than most people expect. You'd assume two suns means double the heat, a scorched, uninhabitable wasteland. Sometimes that's true, but not always. It depends entirely on the setup, and the universe has already shown us more than one option. In 2011, NASA's Kepler space telescope detected a planet called Kepler 16b, orbiting not one star but two, locked together in their own tight orbital dance, roughly 200 light-years from Earth. The discovery was led by astronomer Lawrence Doyle, and it confirmed something scientists had only theorized before. Real Tatooine worlds exist, planets that watch two suns rise and set across their sky, just like in the movies. Kepler 16b itself is a frozen, gassy world, too cold for life, orbiting its two stars once every 229 days. But its existence proved the geometry works. A planet really can orbit two stars in a stable path without being flung into space or torn apart. That single discovery quietly rewrote what we thought was possible. Before Kepler 16b, circumbinary planets, worlds that orbit both stars in a binary system rather than just one, were mostly a mathematical curiosity, something modeled on paper but never confirmed. Doyle's team had to detect two separate, overlapping patterns of dimming light as the planet passed in front of each star at different points in its orbit, a signal so intricate that some astronomers doubted it could even be measured reliably from that distance. It could, and once one was found, more followed. Kepler 16b turned out to be the first confirmed member of an entire growing category of worlds. Now, whether that world stays livable comes down to one brutal factor: distance. If your two suns are close together and you orbit far enough away, their combined light and heat can blend into something surprisingly close to normal. Astrophysicist Rosanne DiStefano, who studies circumbinary planets, has pointed out that in the right configuration, a planet can experience relatively stable seasons and temperatures, not the fiery chaos most people imagine. The two stars essentially act like one slightly stronger source of light from far enough away. But get the geometry wrong, even slightly, and everything changes. If your two suns orbit each other more loosely, with the planet caught somewhere in between, temperatures could swing wildly depending on which star is closer at any given time. Imagine summer arriving twice in 1 year, then a brutal cold snap when both suns are on the far side of your orbit. Your crops wouldn't just fail occasionally, they'd fail unpredictably, on a rhythm nobody could plan around. What do you think that would do to a civilization trying to build a calendar? Ancient humans on Earth built entire religions, farming schedules, and social structures around the predictable rhythm of one sun. A two-sun world would demand a completely different kind of mathematics just to survive, one where next season isn't a guess. It's a genuine unknown. You don't have to imagine this from scratch either. Ancient civilizations on our own single-sun Earth already struggled when their skies became even slightly less predictable. Early Babylonian astronomers spent centuries tracking the erratic movements of the 5 visible planets against the fixed stars, precisely because anything that didn't move in a clean, repeating pattern was almost impossible to plan around. They eventually cracked the code through sheer generational persistence, recording eclipses and planetary positions on clay tablets for hundreds of years, until the patterns finally emerged. Now imagine that same challenge, except the sun itself, the most fundamental unit of time humans have ever measured by, refuses to behave consistently. There may be no clean pattern to find at all. Here's the twist most people don't expect, though. A two-sun sky might not be humanity's biggest problem. Gravity would be. Two stars orbiting each other create a much more complicated gravitational field than the one we're used to. Planets in binary systems have to find very specific, safe zones, orbits stable enough that the pull of both stars doesn't eventually fling the planet away or drag it into one of the suns entirely. This is exactly why Kepler 16b's stable orbit mattered so much to scientists. It proved those safe zones actually exist in nature, not just in equations. Astrophysicist Rosanne DiStefano has since helped map out roughly where those safe zones tend to sit around different binary configurations, work that's now guiding astronomers searching for potentially habitable circumbinary worlds elsewhere in the galaxy. But stable doesn't mean gentle. Even in a safe orbit, a two-star planet is constantly being tugged in two directions, not one. Over millions of years, that tug-of-war can subtly reshape a planet's orbit, its tilt, even its rotation, which means the two-sun sky your grandparents saw might not be quite the same sky your grandchildren see. Try sitting with that for a second. Your entire cultural memory of what the sky looks like could quietly shift within a few generations. Nothing dramatic, no apocalyptic event, just a slow, invisible drift, like watching a clock that's ever so slightly wrong, correcting itself over centuries instead of seconds. There's an even stranger possibility hiding inside that drift. If a planet's tilt shifted enough over time, entire regions could gradually swap seasons. A place that spent centuries as a frozen pole slowly warming into something closer to a temperate coastline, while somewhere else cooled in the opposite direction. Entire civilizations could rise around one climate, only to watch their descendants inherit a completely different one, without a single asteroid impact or war ever taking place. Just gravity, patiently doing its work over deep time. So why does any of this matter to you, on an Earth with exactly one perfectly ordinary sun? Because it reveals something people rarely think about: how much of normal is really just cosmic luck. You don't wake up to 2 sunrises. You don't lose sleep to a second dusk interrupting your night. Your seasons are boringly, reliably predictable, which is precisely why your ancestors could build calendars, plant crops, and plan their lives generations in advance. That predictability isn't guaranteed by the universe. It's a gift from an unusually simple solar system. One star, one dominant gravitational pull, one steady rhythm of light and dark. Most planets we've found orbiting binary stars don't get that luxury. Consider how much of human history actually depends on that single reliable rhythm. Every harvest calendar, every religious holiday tied to a solstice, every clock and calendar system humans have ever built, all of it assumes one sun rising and setting in a pattern so stable you can set your watch to it. Quite literally. Strip that away, and you're not just losing a pretty sunset. You're losing the foundation nearly every human institution was quietly built on top of. There's something almost humbling in that. The single sunset you barely noticed tonight is actually one of the rarer, more fortunate arrangements the universe has to offer. Somewhere out there, on a real Kepler 16b-like world, if anything is watching the sky, it's trying to make sense of 2 suns that never quite behaved the same way twice, never settling into the one simple rhythm your entire biology, calendar, and history were built around. And that's the real reframe here. This was never really a question about alien skies. It was about noticing what you've been living inside of the entire time, every single evening, without ever stopping to think about how fragile and unlikely that quiet, single sunset actually is. Tonight, you'll watch the sun go down the way you always do. Except now, you might actually watch it. Because somewhere out there, a version of you on another world is still waiting for its second sunset to finally begin.